In our project, in iSense project, we develop methodology also not only to detect, validate and correct, but also to isolate the fault and send alarms to the people, to the maintenance people, to reconstruct or to modify the systems in order to have a good systems in real time. We developed this in every benchmark of the project. We apply this methodology with water distribution systems of Barcelona, but also in the environmental system in Italy, and also with the building demonstrator of the iSense.
One of the areas that we worked on is contaminant detection. So if one of the rooms in a large building has contaminant, how do we detect it as quickly as possible? How do we isolate where it is? And we have obtained some interesting results. We have developed a toolbox that you can try different techniques.
Environmental monitoring, think of landslides, rock falls, natural hazards. You want to acquire a lot of data from the environment to make a decision out of the incoming data. The main problem is that if you want to build a fault diagnosis system, which should be able to say whether the data that are coming from the field are good or not, you should rely on some a priori assumption about the process generating the data. That's to say, the system model which allows the sensors to provide data streams. Unfortunately, in environmental monitor, this information is not available, and then the fault diagnosis system has to be built on the top of data streams.
This is a four-wheel motor. We have 4 motors for omnidirectional wheel, so the robot can move along all the directions. The heart of the robot is an STM32F4, is a CPU with more than 200 MIPS, and we have 2 power boards to power the 4 motors, and we have 8 ultrasound sensors. So with this we can understand obstacles in the surroundings. Platform in iSense, we were able to test all the faults and accommodation, fault identification and accommodation algorithms that we developed within iSense. Basically, we inject some fault in one of the components, and then with our algorithm we are able to understand what is the component with the fault, isolate it and compensate it.
One of the big challenges at the beginning was to find a real novel field of application in the context of the project, because at the beginning the project was mainly devoted to, let's say, intelligent buildings. Later on, we realized that to better exemplify the concept of fault tolerant control, maintaining the spirit of the project, that it's in the robotics area, we decided to propose a new platform with other partners of the project based on a robotic application that shows better the benefits and the new methods we are developing in the field of fault tolerant control. And in particular, I think was a success, no? The decision of using a robot, because it's very visual what it means fault tolerant control in this kind of applications. And moreover, in the robotic domain, the fault tolerant control strategies are quite new.
After iSense, I think there's a continuing challenge in terms of dealing with unknown data stream. So we know we receive a lot of data these days, and the data is coming in whether we want it or not. So the real challenge is how do we understand this data? How do we understand the inherent uncertainties within the data? How do we deal with both the dynamics and the uncertainty within the data in order to build a model, and this model can help us in understanding both the scientific challenges and the application-specific challenges.